The observable universe has an edge. In every direction you could point, at a distance of about 46 billion light-years, there is a boundary to what we can see, a wall of the oldest light there is, beyond which nothing has ever reached our eyes. That edge is real, and we have measured how far away it lies. And here is the strange part. You could never get there, not because it is merely far, though it is far past anything the word can hold. You could never reach the edge because the edge is running away from you, and it is running faster than light itself, carried outward by the expansion of space. Chase it at any speed you like, and the gap only widens. In fact, most of what you can see out there tonight is already gone, already beyond any hope of reaching, and more of it slips away with every second that passes. Tonight I want to take you all the way out to that edge, as far as anything can ever go, and show you why no one, anywhere, will ever arrive. The question is not how far the edge is, the question is why nothing can ever touch it. Tonight we are going to travel from the ground beneath you all the way to the edge of the observable universe, across every scale there is, and find out why that edge can never be reached by anyone. By the end of this you will understand how impossibly large the universe truly is, how long it would take to cross even the smallest part of it, what you would pass through on the way out, and why the expansion of space has already placed most of the universe permanently beyond the reach of any traveller for good. I am also going to tell you what this means for everyone else out there, because a universe this size almost certainly holds other civilizations, and the same size that guarantees they exist is the thing that guarantees we will never reach them, and they will never reach us. This is a story about the largest thing there is, and about how being able to see something is not at all the same as being able to go to it. If you like having the floor drop out from under your sense of scale late at night, a quick subscribe brings more of these your way. Now, let us begin. The universe has an edge, and almost nobody pictures it correctly. Ask most people what the edge of the universe is, and they imagine a wall, a far boundary somewhere out in the dark, with empty space or plain nothing on the other side of it. That is not what is out there, but there genuinely is an edge, a real one, and we have measured how far away it lies. So let me tell you exactly what it is before I tell you why no one will ever reach it. Look out into space in any direction you choose, and you are looking not only across distance but backward in time, because light takes time to travel. The sun you see is the sun as it was 8 minutes ago. The nearest stars you see as they were years ago, the nearest large galaxy as it was millions of years ago. Keep looking further to fainter and older light, and you are seeing further and further into the past, to galaxies as they were billions of years ago, when their light first set out toward you. And if you keep going, you eventually reach the oldest light there is, about 46 billion light years away. In every direction at once, there is a point beyond which we cannot see anything at all, because the light from any further has not yet had the time to reach us since the universe began. That distance is the edge of the observable universe. It is a real limit, and it forms a boundary around us in the shape of a sphere, roughly 93 billion light years from one side to the other. Now what actually sits at that edge is one of the strangest things in all of science. It is not a wall of rock or a barrier of any kind, but a wall of light. The oldest light in existence, released a little under 14 billion years ago, when the whole universe was still a hot fog that had only just cooled enough to become clear and let light travel freely. That first light has been streaming across space ever since, and the most distant of it is only reaching us now, faint and stretched and cooled into a dim glow that fills the entire sky. We call it the cosmic microwave background, and it is quite literally the edge of what we can see, a curtain of the universe's own first light hanging at the limit of every line of sight. When you look at the edge of the universe, you are looking at the universe as a newborn, glowing at you from every direction. There is a puzzle hiding in that number, 46 billion light years, and it is worth clearing up, because it reveals that the expansion has been at work this whole time. The universe is only about 13.8 billion years old, so how can the edge be 46 billion light years away, when light has had only 13.8 billion years to travel? Should the edge not be 13.8 billion light years off, and no more? The answer is expansion. The oldest light did travel for about 13.8 billion years to reach us. But while it was traveling, the space it had already crossed kept stretching out behind it, and the point it set out from was carried further and further away. So the light took 13.8 billion years to arrive, and yet the place that emitted it is now, today, about 46 billion light years away, dragged out to that distance by the growth of space during the trip. The edge is far larger than the age of the universe alone would suggest, and the reason is the very expansion that will, by the end of tonight, place almost everything beyond our reach. And there is one more thing about this edge that quietly unsettles everyone who understands it. It is centered on you. Every observer, anywhere in the universe, sits at the exact center of their own observable sphere, their own edge 46 billion light years off in every direction, because everyone can see equally far in all directions from wherever they happen to stand. There is no special center and no privileged spot. A civilization in a galaxy out on our own edge, at the very limit of what we can see, would have its own observable universe reaching 46 billion light years past us on one side and 46 billion light years past their own far edge on the other, most of its space we can never see. So the edge is not one shared wall around everyone at once, but a personal horizon that travels with each observer, and there are as many edges as there are places to stand. Let me say a little more about what that oldest light actually shows us, because it is a genuine baby picture of everything. For the first few 100,000 years after the beginning, the whole universe was so hot and dense that it was not clear but opaque, a glowing fog of particles through which light could not travel freely, much as light cannot pass through the interior of the sun. Then, about 380,000 years in, the universe cooled just enough for that fog to clear, for the loose particles to settle into the first whole atoms, and suddenly light could stream freely across space for the first time. The light released at that moment of clearing is the light we now see as the edge, the microwave glow, stretched and cooled by all the expansion since. So the edge is not only the limit of our sight, but a snapshot of the exact instant the universe became transparent, the oldest thing it is possible to see, the first photograph of all that exists, hanging at the boundary of every direction we look. And how large is the whole universe, the real one, beyond our observable patch? The honest answer is that we do not know, and may never know, but the hints all point the same way, toward enormous, and quite possibly toward endless. The universe is measured to be geometrically flat, so far as we can tell, and a flat universe, if it does not curve back on itself, goes on without end. Even if it is finite, the parts beyond our horizon are thought to be at the very least hundreds of times larger in every direction than the piece we can see, and plausibly far more than that, perhaps without any limit at all. So our observable universe, that 93 billion light-year sphere holding 2 trillion galaxies, may well be a single grain in something infinite, one lit bubble of visibility in a sea that never ends. The edge we can measure is not the size of the universe, only the size of our view of it, and the view may be an unimaginably small fraction of the whole. But here is the thing that matters most, and it changes everything that follows. That edge is not the boundary of the universe. What we have measured is the boundary of the observable universe, which is a very different thing. The edge is not where the universe stops, only where our seeing stops. Beyond that curtain of old light, there is almost certainly more universe, a great deal more, filled with more galaxies, going on, and quite possibly going on without any end at all. We simply cannot see it, because its light has not had time to arrive. The universe may well be infinite. What has an edge is not the universe, but our view of it. So the edge is a horizon, and that word is the key to this whole video, so hold on to it. Think of standing on a ship in the middle of the ocean. You see a line all the way around you where the sea meets the sky, and it looks for all the world like the edge of the water, a boundary you could sail to. But you cannot sail to the horizon. Walk toward it, sail toward it, and it moves away from you, always staying the same distance off, because it is not a place at all, just the limit of how far your eye can reach across the curve of the world. The edge of the universe is a horizon in exactly that sense. It looks like a boundary you could travel to, a wall out there at 46 billion light years. It is nothing of the kind. It is the cosmic version of that line at sea, a limit on seeing, not a fence at the end of the world. I want to be honest about how much of this lies permanently beyond our knowing, because that honesty is part of the story. We cannot see past the edge, and we may never learn anything at all about what is out there, because no light, no signal, nothing from beyond that horizon has had the time to reach us. Everything we say about the universe past our own edge is inference, a reasonable guess based on the fact that everything inside our view looks broadly the same in every direction, so we assume it keeps on in the same way outside. That is a good assumption. It is not something we can ever check. There is a hard limit on human knowledge drawn at that edge, and we sit inside it, able to study our own patch of an ocean whose true size we will never measure. No instrument will ever change that, and no amount of cleverness will get around it, because the barrier is not one of technology, but of time and light itself. Which brings us to the question this whole night is built around. If the edge is a real distance we can point to and measure, 46 billion light years off, then surely, given enough time, given a fast enough ship, and a patient enough civilization, someone could travel there. Surely the edge, however far, is a destination like any other, just very distant. It is the natural thing to assume, and it is completely wrong, and the reason it is wrong is stranger and more final than mere distance. But before I can show you why the edge can never be reached, I have to make you feel how far away it truly is. And that does not start out among the galaxies. It starts right here, at your feet, with the ground you are standing on, because even the smallest steps of this ladder are already almost too large to hold in the mind. To feel the size of the universe, you have to climb it one rung at a time, and the first rungs are already large enough to break the mind. So let us start at the bottom, with the ground beneath you, and climb slowly outward. Begin with the Earth. It feels enormous. A person can spend a lifetime and never see all of it, and yet light, which is the fastest thing there is, moving at 300,000 kilometers every second, could circle the entire Earth 7.5 times in a single second. On the scale we are about to climb, the whole planet is nothing, a mote, a grain, gone before we have properly started. Step up one rung to the sun. Light that leaves the surface of the sun takes 8 minutes to cross the gap and reach the Earth, so the sunlight warming your face left the sun 8 minutes ago. Take one more step out, to Jupiter, the giant of our solar system, a world so large that all the other planets put together would fit inside it with space to spare, more than 1,000 Earths packed into its volume. Sunlight takes about 43 minutes to reach Jupiter, more than 5 times as long as it takes to reach us. And Jupiter, for all its size, is still deep in the sun's own neighborhood, one of just 8 planets scattered through a solar system that is itself mostly empty space. If you shrank the sun to the size of a large beach ball, the Earth would be a peppercorn some tens of meters away, Jupiter a chestnut a few hundred meters off, and the nearest other star, another beach ball, thousands of kilometers distant across otherwise empty ground. Even our own solar system, the one small corner of the universe we have actually touched with our machines, is overwhelmingly nothing, a few small worlds strung across enormous gaps of dark. The emptiness we will meet between the galaxies is not something new. That same emptiness is already all around us, here, at home, between the planets. And that is the lesson of the first rung that people always resist. The universe is not built to human scale, and it is not built to be crossed. Every time we climb one step, from the Earth to the Sun, from the Sun to the nearest star, the gap does not grow a little. It grows by a factor so large that the step before it vanishes into nothing beneath it. The 8 light minutes to the Sun make the whole Earth a speck. The 4 light years to the nearest star make the whole solar system a speck. And as we are about to see, the distances between galaxies make the whole Milky Way, all 100,000 light years of it, a speck in turn. The ladder does not climb gently, one even step after another, each rung swallows the one below it whole. It helps to slow down on the unit itself, the light year, because we throw it around so easily that it stops meaning anything. A light year is the distance light travels in 1 year, and light travels at 300,000 kilometers every second without pause for the whole year. Work that out, and a single light year comes to about 9.5 trillion kilometers. 9.5 trillion. The nearest star, at 4 light years, is nearly 40 trillion kilometers away. The width of our galaxy, 100,000 light years, is a number of kilometers with so many zeros after it that writing it out serves no purpose. And the edge, at 46 billion light years, is that already unthinkable galactic width, multiplied again by hundreds of thousands. Every time you hear the words light years in this video, remember that each one is 9.5 trillion kilometers of hard vacuum, and that we are stacking them not in dozens or thousands, but in billions. And set against all of that, remember what we have actually done. In the whole of our history, the farthest we have physically sent anything is to the near edge of our own solar system, a pair of probes launched almost 50 years ago that have only just crawled out past the planets and are not even the smallest fraction of the way to the nearest star. We have set foot on exactly one other world, our own moon, a mere light second away. That is the entire physical reach of our species so far, a light second of footprints and a few probes creeping toward the first light year. Against a universe measured in tens of billions of light years, we have not left the doorstep. We have barely opened the door. And already, before we have crossed even a single light year to another star, we can say with full confidence that the far edge of everything can never be reached at all. Already the distances have jumped from a fraction of a second to 8 minutes at the speed of light, and we have only reached our own star. Step out past the planets, past Jupiter and Saturn, past the cold outer reaches where our farthest spacecraft are still crawling outward after nearly 50 years of flight, and you leave the solar system entirely. And then there is a gap, a long, dark, empty gap, because the nearest other star to the Sun is more than 4 light years away. Say that number slowly, 4 light years. Light itself, the fastest thing in existence, takes over 4 years to cross from the Sun to its closest neighbour, and our fastest spacecraft, the quickest machines we have ever built, move at around 17 kilometers a second, which sounds tremendous and is nothing at all against this gap. At that speed, to reach even the nearest star, a probe would need something like 80,000 years. 80,000 years to reach the single closest star, when the whole of recorded human history is a few thousand years. We have never done it. We have never sent anything even 1/100th of the way to another star. The fastest, farthest things we have ever launched are still deep inside our own solar system, and will be for many thousands of years to come. Now hold that gap, the 4 light years to the nearest star, and understand that it is a typical gap between neighbouring stars, and that our galaxy, the Milky Way, contains not a handful of stars, not thousands, but somewhere between 100 billion and 400 billion of them. Hundreds of billions of stars, each separated from the next by gulfs of light years, all bound together into a slowly turning disk. And that disk is about 100,000 light years across. Sit with what that means. A beam of light which crosses from the Sun to the Earth in 8 minutes and takes 4 years to reach the nearest star needs 100,000 years just to cross our own galaxy from one side to the other. 100,000 years at the speed of light, simply to traverse the single galaxy we happen to live in, one galaxy among the many we are about to meet. The Milky Way is not a place you could ever cross, but a place you are hopelessly, permanently lost inside. If our fastest probe needs 80,000 years to reach the nearest star, then to cross the whole galaxy, it would need something on the order of 1,000 million years, a length of time comparable to the age of complex life on Earth. No civilization remotely like ours could ever traverse its own galaxy by any means we understand. And this is the first real rung of the ladder, not the universe, not the edge, just our own single galaxy. One island of stars, already so large that crossing it is beyond anything we can seriously imagine. I should be fair and say that these travel times are built on the speeds we can actually reach today, and someone will always point out that future engines might go faster, that a craft at 1/10 of the speed of light, or half of it, would shrink these numbers. That is true, and it changes the arithmetic, and it does not change the verdict at all, because the scales we are climbing grow far faster than any speed we could plausibly reach. Even a ship somehow travelling at the full speed of light, which nothing with mass can ever do, would still need 100,000 years to cross the galaxy, and that galaxy is about to become a single dot in a structure so much larger that the word large stops meaning anything. Speed is not going to save us here. The problem is not that our engines are slow, the problem is the size of the thing, and the size is only beginning. So fix the picture in your mind before we climb again. The Earth, a grain, crossed by light in an instant. The Sun, 8 light minutes off. The nearest star, 4 light years away, and 80,000 years by any ship we have. The galaxy, 100,000 light years wide, 1,000 million years to cross, holding hundreds of billions of stars. That is the ground floor. That is where the ladder begins, not where it climbs to. And when we pull back from the Milky Way and see it from outside as one object among others, the scale does not merely increase, it detonates. Pull back from the Milky Way until the whole galaxy, all 100,000 light years of it, all its hundreds of billions of stars, shrinks to a single glowing disk hanging in the dark, and then keep pulling back, because now the scale begins to climb in a way that quickly stops making sense. And this is the rung the whole video needs you to feel. The Milky Way is not alone. It has companions, other galaxies bound to it by gravity, and together they form a small cluster called the local group. The largest other member is the Andromeda Galaxy, a great spiral much like our own, and it is the nearest major galaxy to us. It is 2.5 million light years away. Look at Andromeda tonight, and the light entering your eye left it 2.5 million years ago, before anything you would recognize as a human being existed on Earth. And Andromeda is our neighbor. It is the close one. The local group as a whole, this little cluster of a few dozen galaxies, is about 10 million light years across. We have gone, in one step, from a galaxy 100,000 light years wide to a cluster of galaxies 100 times wider still. And the local group is nothing. It is a quiet suburb on the outskirts of something far larger. Our little group is being drawn toward and belongs to a much greater collection of galaxies centered on the Virgo cluster. And that in turn is only one district of a truly enormous structure called the Laniakea supercluster. Laniakea contains something like 100,000 galaxies, not 100,000 stars, 100,000 galaxies, each with its own hundreds of billions of suns, and it stretches across more than 500 million light years of space. All of those galaxies, including our own, are slowly sliding through space toward a mysterious central region called the Great Attractor, drawn by the pull of all that gathered mass. Our galaxy is a single glinting speck near the edge of this supercluster, being pulled slowly toward a center we cannot even clearly see. And now the part that should genuinely stagger you. This structure of 100,000 galaxies spread over 500 million light years is itself only one supercluster among millions of them. Superclusters are strung together like beads along immense threads and sheets of galaxies which wrap around gigantic empty spaces, and this arrangement, repeated over and over across the whole observable universe, forms a single pattern that astronomers call the cosmic web. Filaments of galaxies stretching hundreds of millions of light years, meeting at dense knots, surrounding enormous rounded voids of near nothing, the whole thing looking, when you map it, uncannily like a web, or the branching of nerves or foam. Pull back far enough to see the entire observable universe at once, and the 2 trillion galaxies it contains no longer look like galaxies at all. They look like droplets of light strung on invisible threads, glowing faintly across a mostly empty sphere 93 billion light years wide. 2 trillion galaxies. Let me try to make that number real, because it is almost designed to slide off the mind. If you could somehow visit one galaxy every second, naming it and moving on, 1 galaxy per second, without ever stopping to sleep or rest. It would take you more than 60,000 years to count the galaxies in the observable universe. Not the stars, the galaxies. And each of those galaxies holds, on average, 100 billion stars or more of its own. The total number of stars in the observable universe is a figure with something like 22 zeros after it. More stars than there are grains of sand on every beach and in every desert on the entire Earth, many times over. Let me try one more way to make the size land, because numbers this large stop being felt and turn into mere noise, and I do not want that to happen here. Suppose you shrank the entire Milky Way, all 100,000 light years of it, all its hundreds of billions of stars, down to the size of a single dinner plate. On that scale, where our whole galaxy is a plate you could hold in two hands, the Andromeda Galaxy would be another plate about 3 meters away. That much is not so bad. But on that same scale, the observable universe, the whole 93 billion light-year sphere, would be larger than the entire Earth, galaxies as dinner plates, and the universe they sit in the size of a planet. And it is not evenly filled, but webbed and clustered and voided, plates gathered in little heaps, with enormous empty gaps between the heaps. That is the true shape of the thing, and our galaxy is one plate in one small heap, out near the edge of one supercluster, in a universe the size of a world. What gets me most is how new this knowledge is. For almost the whole of human history, nobody knew that other galaxies even existed. Barely 100 years ago, the faint smudges we now know to be distant galaxies were thought by many astronomers to be clouds of gas inside our own Milky Way, and our galaxy was assumed to be the entire universe. It was only in the 1920s that we learnt those smudges were other galaxies, immense and unthinkably far away, each one its own island of hundreds of billions of stars. In a single human lifetime, we went from believing the Milky Way was everything, to mapping 2 trillion galaxies across 93 billion light-years, and discovering that the space between them is stretching. We are the first few generations of our species ever to see the true size of what we live in. And what we found, the moment we could finally see clearly, is that we live in something so large that the seeing is essentially all we will ever be able to do with it. There is a hidden scaffolding holding all of this up, and it deserves a moment, because it makes the web stranger still. The galaxies strung along the filaments of the cosmic web are not even the main thing there. They are the visible froth on top of something far more massive and entirely invisible, called dark matter. A kind of matter that gives off no light and that we detect only by its gravity. There is roughly 5 times as much dark matter as ordinary matter in the universe, and it forms the true skeleton of the cosmic web, immense unseen filaments and knots along which the visible galaxies have gathered like dew, strung along a spider's threads. So when you look at that glittering web of galaxies, you are seeing only the lit parts of a much larger, darker structure, most of which shines with no light at all. The universe is not only mostly empty, even the parts that are not empty are mostly invisible. And all of it, the visible galaxies and the dark scaffolding together, is being carried apart by the expansion, everywhere at once, at every scale above the gravitationally bound clusters. The filaments are stretching, the voids are growing. The whole web is being drawn thinner and wider as the ages pass, the bright knots drifting further from one another, the dark threads between them lengthening. What we map today as the cosmic web is a single still frame of a slow, silent, universe-wide coming apart, and every structure in it, however enormous, is drifting away from every other structure it is not bound to, on the same tide that keeps the edge beyond our reach. The web is not a fixed cathedral of galaxies, only one frozen moment of an endless spreading out. This is the structure we are talking about crossing. This is the thing with an edge. I should be honest about one soft spot in all this, because it matters. The exact boundaries of a supercluster like Laniakea are partly a matter of where you choose to draw the line, since these are not sharp-edged objects but loose, flowing associations of galaxies, and astronomers are still mapping and arguing over exactly where one ends and the next begins. But that softness is at the edges of the definitions, not in the overall picture. The nesting is not in doubt, Stars gather into galaxies, galaxies gather into groups, groups into clusters, clusters into superclusters, superclusters into the filaments and walls of the cosmic web, and the web fills the 93 billion light-year sphere of everything we can see. Each step up is a leap of scale that dwarfs the one below it, and we have climbed from the Earth to the whole observable universe in just a few rungs. So now, at last, you have the true size in view. Not a galaxy, not a cluster. The whole thing, 2 trillion galaxies webbed across 93 billion light-years, with its edge, that curtain of oldest light, hanging at the outermost limit. And with that size finally in front of us, the obvious question comes back, the one from the very start, and it comes back with real weight now. How long would it take to cross this? How long to reach the edge? The honest answer is not a big number. The honest answer is that it cannot be done at all, and the reason why is where this stops being a story about size and becomes something far stranger. How long would it take to reach the edge of the universe? The honest answer is not a large number. The answer is a word, and the word is never. Let me build up to why, because the answer is not the simple one, and the simple one is already crushing enough. Start with the nearest large galaxy, Andromeda, 2.5 million light-years away. Suppose we wanted to send a ship there, at the speed of our fastest current spacecraft, 17 kilometers a second. The crossing to Andromeda would take not thousands of years, not millions, but tens of billions of years, far longer than the universe has so far existed. So that is out. Suppose then we could build the impossible, a ship that travels at the very speed of light, the absolute limit that nothing with mass can ever reach. Even then, the trip to Andromeda, our nearest big neighbour, takes 2.5 million years, one way, because that is simply how far the light itself has to travel. The closest major galaxy to our own, at the greatest speed physically allowed, is a crossing longer than our species has existed. And Andromeda is next door. Andromeda is 2.5 million light-years away, while the edge of the observable universe is 46 billion light-years away. That is not twice as far, or 10 times as far, but roughly 20,000 times as far as Andromeda. If a light-speed trip to the nearest galaxy takes 2.5 million years, then a light-speed trip to the edge, if distance were the only problem, would take tens of billions of years at the very least, longer than the current age of the universe, and that is assuming the ludicrous, a ship at the full speed of light, and an edge that politely stays where it is and waits for you. But the edge does not wait, and this is where the real answer arrives, the one that turns never from a matter of patience into a matter of physics. Space itself is expanding, not the galaxies flying apart through space, but space itself, the very distance between things, growing everywhere, all at once. And the crucial feature of that expansion is this: the farther away something is, the more space lies between you and it, and so the faster that space is growing, and the faster the thing recedes from you. Nearby galaxies drift away slowly, distant galaxies recede quickly, and very distant things recede extraordinarily fast because there is so much stretching space piled up between you and them. Past a certain distance, the space between you and a far-off point is growing so fast that it is being added faster than light itself could ever cross it. The gap widens faster than any traveller or any beam of light could ever eat into it. So imagine doing the fastest thing physically possible. Imagine firing a beam of light, right now, straight at the edge of the universe, and following it. For the first stretch, it makes progress, crossing the nearer galaxies. But as it reaches out toward the more distant regions, the space ahead of it is stretching faster and faster, and the beam finds itself climbing a hill that grows steeper than it can climb. The target is being carried away in front of it, faster than the beam can advance. And so the beam never arrives, it travels forever, outward, endlessly, and the edge stays ahead of it, always receding, never reached, for the entire infinite future. If a beam of light launched today can never reach the edge, then nothing can, because nothing outruns light. The edge is not far. Far is a word for places you could reach if you had enough time. The edge is unreachable, which is a different and far more permanent condition. There is no amount of time that gets you there. Forever is not long enough. I have to be careful and precise here, because this is the one subtle point on which the whole video turns, and it is the point most often mangled. When I say a distant galaxy recedes faster than light, I am not saying anything moves through space faster than light. Nothing does. That law holds absolutely. The galaxy sits quietly in its own patch of space, going nowhere in particular. What is happening is that the space between us and it is expanding. An expanding space has no speed limit at all, because it is not a thing moving from one place to another, it is distance itself increasing. Add up enough expanding space between 2 points, and the total distance between them can grow faster than light, while nothing local ever breaks the rule. It sounds like a cheat, and it is not one. The speed limit simply applies to motion through space, and the expansion of space is a different thing entirely, and it is the loophole through which the whole universe is quietly slipping beyond our reach. It is worth being concrete about speeds, because people always reach for the hope that a faster ship solves everything, and the numbers close that door firmly. Our fastest craft today move at a few tens of kilometers a second, and at that rate even the nearest star is 80,000 years off. Suppose we did enormously better and built a ship that could reach a tenth of the speed of light, 30,000 kilometers a second, far beyond anything we know how to make. At that speed, the nearest star is a little over 40 years away, which sounds hopeful until you remember that the nearest galaxy is 2.5 million light years off, so at 1/10 of light speed, it is 25 million years away, and the reachable pocket beyond it stretches for billions of light years. Push all the way to 99% of the speed of light, which we have no idea how to reach for anything larger than a single particle, and Andromeda is still 2.5 million years away by the clock back home. The distances simply swallow every gain in speed and ask for more. There is one genuine subtlety worth stating fairly, because it is real. For the travelers themselves, moving close to the speed of light, time slows down, so a crew aboard a ship at 99.9% of light speed might feel only years or decades pass during a crossing that takes millions of years as measured back on Earth. In principle, a crew could reach a nearby galaxy within a single lifetime of their own. But this rescues nothing that matters here. The universe outside the ship still ages by millions or billions of years while they travel, their home and everyone in it long dead before they arrive. And the target, if it lay beyond the horizon, still recedes faster than they can ever close on it, however slow their own clocks run. Time dilation lets a traveler reach a near galaxy within their own lifespan, at the price of leaving everything they ever knew millions of years behind. Someone always asks, at about this point, what about the tricks from the stories, the wormholes and the warp drives, the shortcuts that fold space or slip around the light speed limit? It is a fair question, so let me answer it honestly rather than wave it away. These ideas are not flatly forbidden by physics, which is what keeps them alive in fiction and in the occasional serious paper. A wormhole, a tunnel joining two distant points of space, is permitted on paper by the mathematics of general relativity. A warp drive, which would carry a ship inside a bubble of contracting and expanding space, has been sketched out in real equations. But every one of these ideas, looked at closely, demands something we have never seen and have no good reason to think exists, such as exotic matter with negative energy, in amounts and arrangements that may simply be impossible, and that no experiment has ever produced. They are mathematical possibilities, not engineering plans, and the gulf between those two things is enormous. So the honest position is not that shortcuts are proven impossible, but that there is not one shred of evidence any of them can be built, or that the ingredients they would need even exist, and a great deal of reason to suspect they cannot. To rest the reachability of the universe on them is to rest it on hope rather than physics. And even if, against all present understanding, some such shortcut were one day possible, it would not touch the deepest point of tonight, because the expansion of space would still be carrying the distant galaxies apart, still opening the gaps faster than light, And a universe that has placed its far reaches beyond the speed of light does not hand out easy exceptions. The safe and honest conclusion is the one we have already reached. At any speed we have the slightest reason to believe in, the edge, and almost everything short of it, can never be reached. It does nothing against the expanding horizon, and it cannot make the unreachable reachable. The edge stays lost. So the edge cannot be reached, ever, by anyone. And now you know it is not a matter of speed or patience, but a fact welded into the expanding geometry of the universe itself. Which raises a gentler question, and its answer is its own kind of shock. Suppose you set out anyway, hopeless as it is, and travelled outward for as long as you could. What would you actually pass through, out there, on the long road toward an edge you can never reach? The answer surprises almost everyone, because the universe, for all its 2 trillion galaxies, turns out to be far, far emptier than any picture of it suggests. If you set out for the edge, the overwhelming majority of your trip would be spent in near-perfect emptiness, passing nothing at all. That is the truth the crowded, glittering pictures of the universe hide from us. The galaxies and the great glowing walls are not the rule, they are the thin, bright exception, and between them lies almost nothing, on a scale that dwarfs the structures themselves. The cosmic web I described, the filaments and sheets of galaxies, wraps around enormous rounded regions called cosmic voids, and the voids are where most of the universe actually is. A typical void is hundreds of millions of light years across, a rounded bubble of space almost entirely empty of galaxies, where the density of matter drops to something like a single atom in a cubic meter of space. Think about that figure, not a single star or planet in a cubic meter, a single atom. You could travel through the heart of a cosmic void for 100 million years, at any speed you like, and pass essentially nothing, no stars, no worlds, no light nearby, only the occasional lonely galaxy adrift in a darkness so complete that from within it the rest of the universe would be a scattering of dim, distant glows and nothing more. And these voids are not rare pockets. Taken together, cosmic voids fill something like 80% of the entire volume of the universe. 80% of everything is this rounded emptiness, hundreds of millions of light years wide, with almost nothing in it. One of the largest known is the Booter's Void, a roughly spherical region around 330 million light years across, so empty that when it was first found astronomers were unsettled by it. It has been said that if the Milky Way had formed in the centre of the Booter's Void, we would not have known there were other galaxies until well into the 20th century, because the nearest ones would be too far away and too faint to notice. A civilization born in the middle of such a void could grow up believing its single galaxy was the entire universe, with nothing but empty black in every direction for hundreds of millions of light years. That is how much nothing there is in the nothing. Where matter does gather, it gathers into threads, and some of those threads are almost beyond belief in scale. There are great walls of galaxies, sheets and filaments where thousands of galaxies are strung together across distances that beggar belief. One of them, the Sloan Great Wall, is a sheet of galaxies roughly 1.5 billion light years long. Others may be larger still, though the very largest claimed structures are argued over. But the point of the walls is not only their size. What matters is what they border. Each great wall is the bright edge of a void, the place where the thin sheet of galaxies wraps around one of those enormous empty bubbles. The structure of the universe, seen truly, is a structure of emptiness with thin bright films stretched over and between the hollows, like the walls of foam around the bubbles in a head of beer, or the thin membranes around the air pockets in bread. The galaxies live in the films. The volume is in the holes. The thin gas that fills the space between the galaxies is stranger than plain emptiness too. It is not cold, as you might expect of something so sparse. Much of it is fiercely hot, heated to millions of degrees by the slow violence of structure forming across cosmic time. And yet it is so thin, so few atoms spread across such enormous volume, that its heat is almost meaningless, a temperature with almost no substance to carry it. A thermometer drifting in it would barely register a thing, because there is so little there to touch. That is the intergalactic medium the true background of the universe, hot and empty at once, spread so thin across such distances that it is closer to nothing than to something. It is the sea the bright islands float in, and it is very nearly a perfect void. As for the largest structures, the great walls of galaxies that wrap the voids, the honest picture is that we are still finding them and still arguing over them. Beyond the Sloan Great Wall, there are claims of even larger arrangements, sheets and threads of galaxies and bright distant beacons spanning several billion light-years, some so large they strain our theories of how any structure could have formed in the time available. Whether the very biggest claimed structures are single real objects or chance alignments of separate things is genuinely debated among astronomers. But the overall pattern is not in doubt, and the pattern is what matters for the road to the edge. Thin bright walls, sometimes enormous, wrapped around gigantic empty voids, repeated over and over across the whole observable universe, with the emptiness always winning, always taking up most of the volume. Let me walk the first stretch of the road itself, concretely, so you can feel the texture of the crossing. Leave the Milky Way, and at once you are in the near emptiness between galaxies, the local part of the local group, where Andromeda hangs 2.5 million light-years off across a gulf, holding little but a few small dwarf galaxies and thin gas. Reach Andromeda, and beyond it the emptiness deepens, because past the local group lies a stretch of fairly empty space before you come to the richer regions toward the Virgo cluster, tens of millions of light-years away, the nearest place where galaxies truly crowd together. Push through and past Virgo, out across the body of the Laniakea supercluster, and then you reach its thinning edge, and beyond that edge, one of the great voids, hundreds of millions of light-years of almost nothing, to be crossed before the next wall of galaxies even rises into view. And that is only the first few 100 million light-years, the barest opening of a road that runs for 46 billion. The pattern simply repeats, wall and void, cluster and emptiness, over and over, each void a crossing of 100 million years or more, even at the speed of light, each wall a brief thin passage through gathered galaxies before the next emptiness opens. There is no landmark that means you are getting close, because you never get close. There is no thinning of the structure that signals an approaching edge, because the edge is not a place the structure leads toward. You would simply cross void after void, wall after wall, for billions of years, while the expansion carried the whole pattern apart around you, and the edge stayed exactly as far ahead as when you began. The road does not lead anywhere, it only goes on. And there is a cruelty in the arithmetic of that road that is worth spelling out. The further you travel toward the edge, the worse your position becomes, not better. Every year you spend crossing a void, the expansion adds more distance ahead of you than you have covered behind you once you are far enough out. So a traveller heading for the edge does not slowly close the gap, they watch it grow. They spend 100 million years crossing an emptiness, and at the end of it the target is further away than when they set out. There is no other travel in human experience that behaves like this, where effort makes the destination more distant. Walk toward a mountain, and it comes closer, however slowly. Sail toward a far shore, and you arrive, in the end, but move toward the far universe, and the ground opens under you faster than you can walk it, and the harder and longer you try, the more thoroughly you lose. That is what unreachable really means, and it is why no civilization, however patient, however advanced, however long-lived, will ever stand at the edge of everything. There is a particular kind of dark inside those voids that is worth stating plainly, because it is unlike anything in our experience. Deep in the middle of a void, hundreds of millions of light-years across, there is no nearby star to give light or warmth, no planet, no dust, essentially nothing but a scattering of atoms so thin that a cubic meter might hold one. The sky from such a place is not empty, because the distant galaxies are still out there, but they are faint and remote beyond any comparison. Thin smudges of light scattered across an otherwise absolute blackness, giving no warmth and barely any illumination. The temperature of the space itself is only a few degrees above the coldest anything can be, warmed by nothing but the faint microwave glow of the beginning. That is the true default condition of the universe, the state most of its volume is in right now. Not the crowded starry sky we know, but a freezing, near-perfect emptiness with a few far-off lights going on for hundreds of millions of light years in every direction. Most of the universe is like that. The lit places are the exception. And this is the answer to a question people often ask without quite meaning it, which is what you would actually see on the way out. The honest answer is that for the overwhelming majority of the trip, you would see almost nothing change at all. Days, years, centuries, millions of years of travel, and the view would be essentially static. A few faint smudges of distant light hanging in the black, shifting so slowly that no lifetime could register the difference. There is no scenery on this road. There are no landmarks. The structures are so large and so far apart that even at the speed of light, you would spend 100 million years crossing a single void, with the same handful of remote glows barely moving in the sky around you. The great crossings of the universe are not adventures of arrival and discovery. They are unimaginable spans of nothing at all, punctuated so rarely that the punctuation hardly counts, which puts the generation ship dream in a hard light. And it is worth being honest about that too. People sometimes imagine that if a crossing takes too long for one life, we simply build a ship where generations live and die on the way, handing the mission down to children who never knew the world they left. That works, on paper, for a nearby star, where the crossing takes centuries. It does not scale to any of the distances that matter tonight. A crossing to the nearest galaxy at any speed we could plausibly reach would need not generations but hundreds of thousands of generations. A closed world, sealed for tens of millions of years, longer than our species has existed by a wide margin, and the target would still be inside our own small reachable pocket. To attempt anything beyond the pocket is to sign up a chain of descendants for a trip that physics guarantees can never end in arrival. There is no version of patience, no arrangement of lifetimes, no depth of commitment that solves an expanding gap. The universe does not reward endurance here, it simply outruns it. And even the bright places, the galaxies themselves, are mostly empty. The space between the stars inside a galaxy is enormous compared to the stars, and the space between the galaxies is emptier still. The thin gas that drifts in intergalactic space, the medium between the galaxies, is so sparse that it amounts to roughly a single atom in a space the size of a small box, a near vacuum far beyond anything we could ever create in a laboratory. And it is spread across distances that make the word empty feel inadequate. So the true texture of the road to the edge is this: long, long crossings of almost total nothing, 100 million light years of void, where you would pass a handful of lonely galaxies at most, broken occasionally by the thin bright wall of a filament, and then more void, and more, on and on. The universe is not a crowded place with a far wall around it, but an ocean of emptiness with rare islands of light, and the emptiness is almost all of it. There is something worth sitting with in that emptiness, because it reframes the loneliness we are building toward. Even if you could somehow cross that distance, even if the edge would hold still and let you approach, the trip itself would be an almost endless passage through the dark, the galaxies so far apart that for the great majority of the way there would be nothing near you at all. The bright, busy universe of the pictures is a trick of compression. Everything interesting squeezed together for the eye. Spread it out to its true scale, and it is mostly a void, and the road to the edge runs through the emptiest places that exist. But I have been talking about the expansion of space as if it were a small footnote, a gentle drift, and it is not. Expansion is the single most important force in this entire story, the thing that turns the edge from far into unreachable, and that will in the end carry almost the whole universe out of our grasp. So before we go any further out, we have to stop and look directly at it. What exactly is expanding? What is stretching? And why can it possibly outrun light? The universe is expanding, and almost everyone pictures that wrong too. So let me clear it up, because once you see what expansion really is, the unreachable edge stops being a mystery and becomes an obvious consequence. When people hear that the universe is expanding, they usually imagine an explosion, galaxies flying outward through space like fragments from a bomb, hurtling away from some central point. That picture is wrong in every important way. The galaxies are not flying through space. They are, for the most part, sitting still in their own patches of space, drifting only slowly. What is growing is the space between them. Distance itself is increasing everywhere, all at once, with no center and no edge to the expansion. The galaxies are not rushing apart within space. Space itself is swelling, carrying the galaxies along with it as it grows. The classic way to feel this is to imagine dots drawn on the surface of a balloon. Blow the balloon up, and every dot moves away from every other dot. Stand on any one dot and look around, and all the others appear to be fleeing from you in every direction, as though you were the center. But there is no center on the surface of the balloon. Every dot sees exactly the same thing. No dot is moving across the rubber. The rubber itself is stretching, and that carries the dots apart. Or think of a loaf of raisin bread rising in the oven. As the dough swells, every raisin drifts away from every other raisin, though no raisin is crawling through the dough. The dough between them is expanding. That is what space is doing, everywhere, all the time, and the galaxies are the raisins, carried apart on the swelling of space itself. We did not always know any of this. For most of human history, the universe was assumed to be static and fixed, the stars and whatever lay among them, holding their places without change. It was only in the 1920s that an astronomer named Edwin Hubble, measuring the light of distant galaxies, found that almost all of them were receding from us, and that the farther away a galaxy lay, the faster it was going. That relationship, the farther, the faster, is the fingerprint of expanding space, and it is measured to this day with ever greater care. The exact rate of that expansion, how fast a given stretch of space is growing, is one of the most important numbers in science, and pinning it down precisely is still an active and slightly contentious effort, with different methods giving slightly different answers. But the fact of the expansion and the pattern of farther meaning faster has been beyond doubt for 100 years. I should be careful with the balloon and the bread, because like all comparisons, they mislead if pushed too far. The surface of a balloon is a good picture because it has no center and no edge, every point equal, everything receding from everything, and that is genuinely how our space behaves. But do not picture the balloon swelling into the air around it, into some larger space it is filling up, because that is exactly the part that does not carry over. Our universe is not expanding into anything. There is no outside for it to grow into, no empty region beyond that it is spreading through. Space itself is simply becoming more of itself, more distance appearing between things, with no exterior at all. That is genuinely hard to hold in the mind, because everything in our experience expands into something. But the expansion of the universe is the growth of the only space there is, from the inside, with no outside, and the galaxies ride along on that growth, like marks on a surface that is becoming larger without being anywhere. The evidence for all of this is not a guess or a story. All of it is written in the light itself, in a way anyone can follow. When light travels across expanding space, the space it crosses stretches while the light is still in flight, and this stretches the light too, drawing its waves out to longer wavelengths, shifting its color toward the red end of the spectrum. This is called redshift, and the further away a galaxy is, the more space its light has had to cross, and so the more its light is stretched, and the redder it appears. We measure this shift in the light of distant galaxies directly and precisely, galaxy after galaxy, and it climbs exactly in step with distance, which is the plain fingerprint of expanding space. The deeper we look, the more redshifted the light, because it has been swimming across more and more stretching space to reach us. The oldest light of all, the microwave glow at the edge, is the most stretched of everything. It set out as fierce hot light, the glare of a universe at thousands of degrees, and across 13.8 billion years of expansion its waves have been drawn out by a factor of more than 1,000, cooling it all the way down into faint microwaves, just a few degrees above the coldest temperature there can be. That cooling is a direct measure of how much the universe has expanded since that light was released, and it matches what the theory predicts almost exactly. So the expansion is not an assumption we bolt onto the universe. We read it straight off the colors of the sky, from the reddening of the galaxies to the deep chill of the first light, and it all tells one story of a space that has been stretching this whole time and stretching faster as it goes. Now here is the feature that matters most for the edge, and it follows directly from the picture. On the rising loaf, two raisins that are close together drift apart slowly, because there is only a little dough between them to expand. But two raisins far apart drift away from each other quickly, because there is much more dough between them, and all of it is swelling at once, and it all adds up. The farther apart two things are, the faster the space between them grows, and so the faster they recede. This is a measured fact about our universe, one of the most important in all of astronomy. Nearby galaxies drift away from us gently. More distant galaxies recede faster, and extremely distant galaxies recede extremely fast, because there is so much expanding space stacked up between us and them that the growth of all of it together carries them away at tremendous speed. Follow that to its conclusion and the loophole appears. If recession speed keeps rising with distance, then at some distance the space between us and a far-off galaxy is growing so fast, adding up over so much stretching distance, that it exceeds the speed of light. The galaxy is not moving through space faster than light, remember, nothing is. But the space between us is expanding faster than light can cross it, and so light from that galaxy, setting out toward us, loses ground, and light from us, setting out toward it, can never arrive. Beyond that distance, the gap grows faster than light can ever close it. That is the whole reason the edge cannot be reached. It is not far in the ordinary sense at all, but beyond a horizon of expanding space that outpaces light itself. And now the twist that makes it final, the discovery that turned a merely large problem into a permanent one. For a long time, astronomers assumed the expansion must be slowing down, that the gravity of all the matter in the universe would gradually pull the brakes on the swelling of space, perhaps even reverse it one day. Then, in the late 1990s, careful measurements of distant exploding stars revealed something nobody was ready for. The expansion is not slowing down, it has been speeding up. Space is stretching faster and faster as time goes on, the gaps between distant galaxies opening at an accelerating rate. Something is pushing the universe apart, overwhelming the inward pull of gravity, and growing more dominant as the universe grows. We do not know what it is. We call it dark energy, a name that is really a label for our ignorance, and it appears to make up around 68% of everything in the universe, more than 2/3 of all there is, and its effect is to drive the expansion ever faster, which means the distance beyond which things recede faster than light is not a fixed, distant boundary we might one day engineer our way around. That horizon is actively, relentlessly closing in. So this is the engine under the whole story. Space expands everywhere. Farther means faster. Past a certain line, faster than light, and the whole thing is accelerating, driven by a dark energy we cannot explain, tightening the noose year by year. I want to be honest that dark energy is a genuine hole in our understanding, one of the deepest in all of physics. We do not know what it is, only how it behaves, and if it were somehow to change its behavior in the far future, the story could bend. But nothing we observe gives any sign of that. On everything we can measure, the expansion accelerates and the horizon closes, which forces the question that turns this from grand abstraction into something that grips your own sky. If there is a line out there beyond which nothing can ever be reached, then how much of what we see is already on the wrong side of it? The answer is the moment this whole video has been building toward, and it is worse than you are expecting. Most of the universe you can see tonight is already gone. Not gone from view, gone from reach. Right now, tonight, the great majority of the galaxies whose light is falling into your eyes are permanently beyond any hope of ever being reached, by us or by anyone, forever. Let me show you exactly how that can be true, because it is the hardest and most important fact in this whole night. We established that beyond a certain distance, space expands faster than light can cross it. That distance has a name. It is called the cosmic event horizon, and for our universe it sits at around 18 billion light-years. Here is what it means, stated plainly. Any galaxy closer to us than that line, we could in principle still reach, or at least send a signal to, if we set out at or near the speed of light, because light can still, just barely, win the race against the expanding space in between. But any galaxy beyond that line is lost. The space between us and it is growing faster than light can ever cross. So a beam of light we send toward it today will travel outward forever and never, ever arrive. Not in a billion years, not in a trillion, never. The event horizon is the true limit of the reachable universe, and it lies at around 18 billion light-years, while the edge we can see lies at 46 billion. The reachable universe is far smaller than the visible one. And now the fact that reorders everything. Of the roughly 2 trillion galaxies we can see in the observable universe, around 94% of them are already beyond that event horizon. 94%. Right now, tonight, more than 9 out of every 10 galaxies in the sky are already unreachable, already past the line, already receding faster than light can ever cross to them. We can see them. Their old light, which set out long ago when they were closer and the expansion had not yet carried them away, is still arriving, still painting them onto our telescopes. But the galaxies themselves, as they are now, are gone. If we launched a beam of light at any one of them this instant, it would never get there. We are looking at more than 1.5 trillion galaxies that we, and any civilization anywhere near us, can never touch, never visit, never signal, never reach by any means permitted by the laws of physics, no matter how much time we are given. Their light reaches us. We can never reach them. Seeing them is all we will ever do. Sit with how strange that is, because it breaks the assumption we have carried since the cold open. We have been asking how long it would take to reach the edge at 46 billion light-years, as though the edge were the hard part and everything nearer were within reach. It is the reverse. The edge was never the real limit. The real limit is the event horizon at 18 billion light-years, and it is far closer than the edge, and most of what we can see already lies beyond it. Only a small pocket of the nearest galaxies, a few percent of everything in the sky, is even reachable in principle. Cosmologists actually carve the universe around us into 4 regions, and laying them out makes the strangeness exact. There is the reachable region, everything within about 18 billion light-years, the galaxies we could still, in principle, send a ship or a signal to. There is a second region, from about 18 out to about 46 billion light-years, galaxies we can see, whose light still reaches us, but which we can never reach, already past the event horizon. There is a third region, from about 46 out to about 62 billion light-years, galaxies we cannot see yet, but whose light is still on its way and will arrive in the future, so they will enter our view, even though we can never touch them. And beyond about 62 billion light-years lies the fourth region, the truly forever hidden galaxies whose light will never reach us at any point in the entire future, sealed away completely, unseen and unseeable for good. 4 zones, nested one inside the next, and only the innermost, the small central pocket, can ever be reached. There is a real paradox tucked into those 4 regions, and it is worth pausing on. In the future, we will actually be able to see more of the universe than we can today, because light from that third region, out between 46 and 62 billion light-years, is still arriving and will bring new galaxies into view over time. And yet, at the very same time, we will be able to reach less of it, because the accelerating expansion keeps pushing more galaxies across the event horizon and out of reach. So the visible universe and the reachable universe move in opposite directions. What we can see slowly grows. What we can touch steadily shrinks. We are being granted a wider and wider view of a universe that is, at the same moment, slipping further and further beyond our grasp, as though it were drawing the curtains open wider, precisely as it bolts the doors. To feel how strange seeing without reaching truly is, take a single concrete case. Our best telescopes have now captured galaxies so distant that their light has been travelling for more than 13 billion years, galaxies we see as they were when the universe was very young, mere infants shining in the early dark. When we look at one of them, We are seeing light that left it over 13 billion years ago. But because of all the expansion since, that galaxy, if it still exists, is now something like 30 billion or more light years away, far beyond the event horizon, receding faster than light can ever cross to it. So we are studying a detailed image of a real place, its shape and its color and its chemistry, a place that is, at this very moment, utterly and permanently unreachable, and has been for billions of years. We know it intimately. We can never go near it. The photograph in our telescope and the object itself parted ways long ago, the image still arriving while the thing has vanished over the horizon. That is the true condition of almost the entire visible universe. Nearly everything in our deepest images is a portrait of a past that can never be revisited, light from galaxies since carried beyond reach, still arriving, still full of information, and completely severed from any road we could travel. We are surrounded by the light of places that are already gone. The sky is a gallery of the unreachable, hung with the portraits of 1 trillion and more galaxies we can study without end and never touch. And the strangest part is that it does not look like a wall or a barrier at all, but like a clear, open, star-filled sky, inviting and near, giving no hint that almost everything in it is already on the far side of a line that nothing will ever cross. The rest, the overwhelming majority of the visible universe, is like a view through sealed glass that will never open. A painting of places that already lie on the far side of a line no traveller and no signal will ever cross. We do not live in a universe we could explore given enough time. We live in a tiny reachable pocket, surrounded by an enormous visible universe that is already, permanently, out of our hands. Let me light a beam of light one more time and send it out, because this is where the image lands hardest. Aim it at a galaxy just inside the event horizon, and, given enough billions of years, it arrives. Aim it at a galaxy just outside that line, only a little further, and it never arrives. Not in the whole infinite future, because the expanding space ahead of it wins the race by the barest margin, forever. That line, that thin boundary between the galaxies light can still reach and the galaxies it never can, runs right through the sky over your head, and 94% of what you can see is on the wrong side of it. The edge of the universe was a horizon that runs from us, but the true horizon, the one that matters, is far closer, and most of the universe is already behind it. I want to be careful and honest with the figures, because precision matters, and this is a claim worth getting right. The exact position of the event horizon depends on the details of the model and on the assumption that dark energy stays constant, and you will see it quoted anywhere from about 16 to about 18 billion light-years depending on how the distance is defined. The exact percentage of unreachable galaxies shifts a little with those choices too. But the conclusion is robust and thoroughly mainstream, agreed on by the people who work on this. The great majority of the galaxies we can see are already permanently unreachable, and only a small fraction of the visible universe can ever be reached by anyone starting from here. That is not a fringe claim or a trick of wording, but the straightforward consequence of an expansion we have measured directly. And if that were the whole of it, it would be enough to sit with for a long time. But it is not the whole of it, because that reachable pocket, the small bright region we could still cross, is not even holding still. That pocket is shrinking. There is a future waiting at the end of all this, a long way off, that makes the universe stranger and lonelier than anything I have said so far, and I promise I will come to it, but not yet. First, I want to show you that the ground itself is shrinking under our feet, and what that means for the countless others who must be out there in the dark with us. The reachable universe is shrinking. The small pocket of galaxies we could still cross is not a fixed territory we simply have not gotten around to exploring. What we have is a shore that is eroding, and every year a little more of it slips into the sea and is gone for good. Here is why. The event horizon, that line beyond which galaxies recede faster than light, is not a fixed fence sitting patiently out there, because the expansion of space is accelerating. That line is closing in. Galaxies that are reachable today, sitting just inside the horizon, are being carried outward by the swelling of space, and one by one they drift across the line and pass beyond reach. A galaxy that we could, in principle, send a signal to this year will, in some far future year, have crossed the horizon, and after that no signal, no ship, nothing from us can ever catch it again. The reachable pocket is not being added to. Instead, it is being subtracted from, steadily, permanently, as the accelerating expansion pushes more and more of what was once reachable out past the line and into the unreachable dark. The island of everything we could ever touch is losing ground at its edges, and the ocean of uncrossable, expanding space around it is widening with every passing moment. Now, the galaxies do not simply blink out when they cross the line, and the way they actually leave is eerie and worth understanding. As a galaxy is carried further from us by the expansion, its light is stretched by that same expansion on the way to us, shifted toward the red end and beyond, growing dimmer and redder and slower. As it approaches the horizon, its light stretches further and further, its image fading and reddening, the galaxy appearing to slow down and freeze and dim rather than vanish all at once. In the limit, it fades toward black, its last light stretched into wavelengths too long and too faint to detect, hovering at the horizon like something falling toward the edge of a waterfall in slow motion, never quite seen to go over, but gone all the same. So the sky does not empty suddenly, it fades. The unreachable galaxies still glow at us for a long while with their old light, reddening and dimming across the ages, while the galaxies themselves are already gone beyond recall. What we see is a memory. What is really there is receding dark. Even the oldest light, the microwave glow at the very edge, is not spared this slow fading. The expansion stretches it too, cooling and thinning it further with every passing age, so that the curtain of first light now filling our sky will, across the long future, be drawn out into wavelengths so long and so faint that it becomes undetectable, and then it too is effectively gone. The very signal that tells us how the universe began is on the same slow tide as everything else, carried over billions of years toward the point where it can no longer be read. Nothing in the sky is permanent. Everything distant is leaving, from the nearest unreachable galaxies to the first light of the beginning itself. All of which means we are living, right now, in something worth calling a golden age of seeing, though it does not feel like one, because it is simply the sky we were born under. The galaxies are still there to look at, the expansion is still measurable, the beginning still glows at the edge. Every piece of the puzzle is still, for now, within view. A civilization that arose much earlier than us would have found the universe too young and hot and formless to read. A civilization that arises much later will find it too spread out and faded and dark to read. We happen to fall in the narrow, well-lit middle, the span in which the universe is old enough to be understood and young enough to still be seen. It is a genuine piece of cosmic luck, and most people live and die without ever noticing they are inside it. It is worth being clear about what actually stays, because in all this leaving there is one thing that does not leave, and it matters for the ending. Gravity, on small enough scales, is stronger than the expansion. Within a galaxy, within a cluster of galaxies tightly bound by gravity, the expansion does not pull things apart, because the local pull of matter wins. So our own galaxy is not flying apart, and the local group, our small bound cluster of a few dozen galaxies, is held together and will stay together. Everything within that gravitationally bound island remains reachable, in principle, without end. It is only the far larger universe beyond the local group, everything not bound to us, that is being carried away. The line between what stays and what goes is the line between what gravity has managed to bind and what it has not, and almost everything, on the scale of the whole universe, falls on the far side of that line, unbound and leaving. So the true and final extent of our reachable universe in the deep future is not even the small pocket of galaxies we can reach today, but something smaller still, because that pocket shrinks until it settles down to just our own gravitationally bound group, and in time to the single merged galaxy that group becomes. That merged galaxy is the permanent island, the whole of what any descendant of ours could ever, in the longest run, touch or visit or live in. Everything else, the 2 trillion galaxies, the great walls, the deep fields full of ancient light, all of it drifts away and is gone. The universe hands each civilization, in the end, exactly one galaxy to call reachable, its own, and takes back all the rest. We began tonight asking whether anyone could cross the whole universe. The final answer is that no one even keeps more than a single galaxy of it. There is one more consequence of the accelerating expansion that is easy to miss and worth stating, because it shows how thoroughly the door closes. As the ages pass and the expansion runs faster, the growth of large structures in the universe stops. Right now, gravity is still assembling things, still drawing galaxies into clusters and clusters into the knots of the Webb, still building, but that building slows as the expansion strengthens, and within a few tens of billions of years it effectively halts altogether, because the space between unbound structures is opening faster than gravity can pull them together. Nothing new gathers after that. The cosmic web reaches its final arrangement and then simply comes apart, its bound pieces drifting from one another without end. Whatever structure exists at that point is all the structure the universe will ever have. Even the assembling stops, and after it, only the leaving continues. There is one last twist in the shrinking that I find genuinely eerie, and it concerns what the sky will look like in the meantime. Because the galaxies fade rather than vanish, and because their light stretches ever redder as they go, the sky of the far future will not empty cleanly. It will grow dim and red first, the distant galaxies smearing into faint crimson blurs, then into infrared invisible to any eye, then into nothing detectable at all, one by one, over billions of years. Anyone watching across that span, if anything is left to watch, would see the universe slowly redden and dim around them, the light of the deep sky bleeding away toward black, the stars of their own galaxy holding steady, while everything beyond them faded like a photograph left in the sun. The leaving is not a disappearance, but a long, slow dimming, and every galaxy in the sky is already, imperceptibly, doing it. And this is not something peculiar to us, to our galaxy, or our vantage point. Every galaxy in the universe sits at the center of its own observable universe, with its own edge and its own event horizon, its own small pocket of reachable neighbors surrounded by an enormous visible but unreachable beyond. Every civilization that exists anywhere, on any world, in any galaxy, is marooned on its own shrinking island of reachable space, watching its own sky slowly redden and thin as its own reachable galaxies drift over its own horizon. The predicament is universal. It is built into the geometry of an accelerating universe. No one is exempt, no vantage point is special. Everywhere, the same slow erosion, the same widening dark, the same handful of reachable neighbors dwindling toward none. There is one mercy in the timing, and I want to be honest about it so the fear stays accurate rather than inflated. All of this plays out over billions and tens of billions of years, not over a human lifetime, not over the lifetime of a civilization, not over anything we would feel. No galaxy is going to visibly wink out in your lifetime, or your descendants' lifetimes for many, many generations. On the timescales we live on, the sky is stable and full, the erosion is real, and it is relentless, but it is unimaginably slow by human reckoning. So this is not a warning about something coming for us soon, but a statement about the deep structure of time, about the direction the universe is permanently heading, and about the fact that we happen to live early while the reachable pocket is still relatively full and the sky still crowded with light that can for now still reach us. But hold on to the direction, because the direction is what matters, and the direction never reverses. Under everything we understand about dark energy, the reachable region only shrinks, the horizon only closes, the sky only thins, on and on, for the entire future of the universe. We are not in a stable situation that happens to be large, we are in a slowly closing one that happens, right now, to still be open. And that fact reaches out and touches the oldest question we have about the universe, the one the summary asked most sharply. If the universe is this size, surely it is full of others. Surely among 2 trillion galaxies and their uncountable worlds, we are not alone, and we very likely are not. But the same expansion that is closing our horizon has a brutal answer waiting for what it means to share a universe this large, and it is not the answer anyone hopes for. The universe is almost certainly full of other civilizations, and we will almost certainly never reach a single one of them. Both halves of that sentence are true at once, and they are true for the same reason, which is the size of the universe. The very bigness that all but guarantees others exist is the bigness that guarantees we can never reach them. Let me take the two halves in turn. First, the others. Consider the numbers we have climbed through. 2 trillion galaxies, each holding, on average, well over 100 billion stars. A great many of those stars with planets, we now know, because we have found thousands of them and the count keeps rising, and the galaxy appears to be thick with worlds. So the number of planets in the observable universe is a figure with something like 22 or 23 zeros after it. Even if the chance of life arising on any given suitable world is extraordinarily small, even if the further chance of that life becoming a civilization is smaller still, you are multiplying those small chances by a number so enormous that the honest expectation is that it has happened many, many times over. We have no proof, we have found no one, but the reasonable inference from the sheer scale is that the universe is not empty of minds, that out there, scattered across those 2 trillion galaxies, there are almost certainly others, some of them long dead, some perhaps yet to arise, some out there right now under their own strange suns, looking up at their own skies. And now the second half, the cruel one. Where are they? Overwhelmingly, they are beyond our reach, and we are beyond theirs. Remember what we established, around 94% of the galaxies we can see are already past our event horizon, already receding faster than light can cross to them. So the overwhelming majority of all those probable civilizations living in all those probable galaxies are in the unreachable 94%. We could never send them a signal. They could never send us one. Even if they are broadcasting with all their might, even if we are, the expanding space between us grows faster than the signal can travel, and it never arrives. And from their point of view, we are in their unreachable majority too, a galaxy already fallen past their horizon, glowing at them with old light, while being, in truth, forever out of their reach. The universe could be teeming, crowded, alive with civilizations in every direction, and almost every one of them would be permanently, physically sealed off from almost every other, each in its own small pocket, calling out into a dark that swallows the cool. You might ask, what about the few that share our pocket? Within our own reachable island, the small handful of galaxies still inside the horizon, could we not at least reach a neighbor there? And in principle, yes, barely, but recall the distances. Even the nearest large galaxy, Andromeda, is 2.5 million years away at the speed of light. To cross to any galaxy at all takes millions of years at the fastest speed physically possible, through those oceans of void we walked through earlier. So even within the reachable pocket, contact between civilizations in different galaxies is extraordinarily hard, a matter of millions of years and unthinkable distances. And beyond the pocket, across the great gaps, it is not hard, but flatly impossible. The size that makes others near certain to exist is the same size that spreads them so thin and pushes them so fast apart that meeting is all but ruled out. There is a particular loneliness in this that is worth naming plainly, because it is not the ordinary loneliness of thinking we might be alone. This is the opposite, and somehow it is worse. We are probably not alone. The universe is probably full, and it does not matter, because full or empty, the result for us is nearly the same. A universe empty of all other life, and a universe crowded with unreachable life look, from the inside of our pocket, almost identical. Either way, we will see no one, meet no one, hear from no one across the great gaps. The others, if they are there, are not hidden or shy or waiting to be found. They are sealed away by the geometry of expanding space, as we are sealed away from them, each of us alone in a crowd we can never touch. This also throws the old puzzle of cosmic silence into a harder light. People often ask why, if the universe is so likely to be full of life, we have never heard a whisper from anyone, no signal, no beacon, nothing but silence in every direction we listen. There are many possible answers to that question for the nearby case within our own galaxy, and none of them are settled. But for the universe at large, for the 94% already beyond our horizon, the silence needs no special explanation at all. We hear nothing from them because we can hear nothing from them, ever, by the plain physics of expanding space. Their signals, traveling at the speed of light, cannot cross the widening gap any more than our ships or our own signals could cross it toward them. The great silence of the distant universe is not a mystery waiting to be solved. That silence is the guaranteed sound of a universe expanding faster than light can bridge, a silence built into the geometry, and it would be exactly as deep whether those far galaxies are empty or crowded with voices calling out. And it works in every direction at once, which is the part that makes it feel less like distance and more like a wall. It is not only that we cannot reach them, any signal they send toward us, any message, any sign of their existence, meets the same expanding space and can never arrive either. So even pure information, even the faintest radio whisper moving at the speed of light, cannot cross the gap. The isolation is total, and it is symmetric. Whatever lies out there beyond the horizon, however grand, however loud, however desperate to be heard, is as silent to us as if it had never existed, and we are as silent to it. 2 trillion galaxies, and almost every one of them locked in a mutual quiet that no amount of effort or technology or time can ever break. That leaves the nearer question. The one expansion does not settle, which is why we have heard nothing even from our own galaxy, the one place close enough that signals could in principle reach us. The Milky Way alone holds hundreds of billions of stars, many of them far older than the Sun, many with worlds of their own, and yet in all our listening we have found no clear signal, no beacon, no sign of anyone. This is the famous silence, and unlike the silence of the distant universe, it has no easy answer. Perhaps life is far rarer than the raw numbers suggest. Perhaps civilizations are common but short-lived, flaring and dying before they can be heard. Perhaps they are out there and simply quiet, or listening as we are, or speaking in ways we do not recognize. We genuinely do not know, and honesty demands admitting that the nearby silence is an open puzzle, not a solved one. But notice how the expansion reframes even this. Suppose the Milky Way does hold others, and suppose one day we even reach a few of them, within our own galaxy, or the nearest bound neighbors. Even then, that small local company is the absolute most any civilization can ever hope for, because everything beyond the bound group is sealed away by expanding space for good. The best case, the most hopeful version of the future, is not a universe of contact and travel between the galaxies. What we get is a single galaxy, or a small bound handful, within which a few neighbors might one day be found, adrift in a universe of 2 trillion others that can never be reached. Even at its most crowded and connected, the reachable world is one galaxy wide. The rest is silence, and the silence is permanent, and it is the same in every direction for everyone. So let me leave you with a real question, and I do not think it has a clean answer, and I would rather hand it to you honestly than pretend to resolve it. If the universe is almost certainly full of other civilizations, but not one of them can ever be reached or even signaled across the expanding dark, then does their existence actually mean anything to us? Are we comforted to know we are probably not alone, even though we will never meet a soul of it? Or is a companionship that can never, under any circumstances, be reached simply the same as solitude wearing a hopeful mask? I have my own feeling about it, but I think it genuinely belongs to you. Sit with it. Because there is one more turn still to come, the future I promised you back at the halfway mark, and it takes this loneliness and makes it deeper and stranger than anything yet, by emptying the sky completely. There is a future coming in which the sky is empty, not sparse, not dim, but empty, a black sky with a single galaxy in it and nothing else anywhere. And that future is the natural end of everything we have been describing. This is the turn I promised at the halfway mark, and it is the strangest and loneliest fact in all of cosmology, so let me walk you into it carefully. Start with what stays. Not everything is being carried away from us. Our own galaxy, the Milky Way, and its close companions in the local group are bound together by gravity. And gravity, on these small scales, is stronger than the expansion, so the local group holds. It does not fly apart. In fact, gravity is drawing its members together, and in a few billion years the Milky Way and Andromeda, the two great galaxies of our little cluster, will fall into each other and merge, their stars swirling together into a single larger galaxy. Over further billions of years, the rest of the local group will merge in too, until what remains is one enormous galaxy, the ground down and combined remnant of everything gravity managed to hold onto. That merged galaxy will endure. It is our island, and it stays. But everything beyond it leaves. Every other galaxy in the universe, every one of the 2 trillion, all of them outside our small gravitationally bound group, is being carried away by the accelerating expansion, and as the ages pass they recede faster and faster, their light stretching and reddening and dimming, until one by one they cross our horizon and fade toward black. This is not quick. It unfolds over tens and hundreds of billions of years, but it is certain under everything we understand, and it is relentless. Give it long enough, roughly 100 billion years and beyond, and every galaxy outside our own merged island will have receded past the horizon and faded from view entirely. The night sky of that era, seen from a world in that final galaxy, will contain the stars of that one galaxy, and then, beyond them, nothing. No other galaxies, no distant glows, no faint smudges of light from far away, just the one island of stars, and around it, in every direction, total and endless dark. Now here is the part that genuinely chills me, the part that turns this from a sad picture into something profound. Imagine a civilization arising in that far future galaxy, 100 billion years or more from now, intelligent, curious, building telescopes, asking the same questions we ask. They look out at their sky, and they see their own galaxy, and beyond it, they see nothing at all, because everything else has long since crossed the horizon and faded. And so, no matter how brilliant they are, no matter how good their instruments, they would have no way of knowing that the rest of the universe was ever there. They would see no other galaxies, so they would conclude their single galaxy was the whole of existence. They would detect no expansion, because there would be nothing left in the sky to see receding. They would find no evidence of the Big Bang, because the oldest light, the microwave glow that fills our sky and tells us how the universe began, will itself have been stretched and diluted by the expansion into something undetectable. Every clue we used to piece together the history and shape of the universe would be gone, carried beyond their horizon, or thinned into nothing. They would look out at an empty sky around a lonely galaxy and reasonably, carefully, scientifically conclude that this was all there is and always had been. The truth would be permanently, physically unavailable to them. And that empty sky is not even the end of the story, only a waypoint on a road that grows darker still. Long after the other galaxies have vanished, the stars themselves begin to run out. New stars stop forming as the gas is used up. The existing stars burn down one by one, the bright ones quickly and the dim red ones over spans of trillions of years, until the last of them gutters out and the final galaxy goes dark. After that, over stretches of time that make everything we have discussed look instantaneous, even the dead remnants decay, and the great black holes that anchor the galaxies slowly evaporate. Over numbers of years it is pointless even to name, until nothing is left but a thin, cold, featureless dark stretching on without end. That is the far destiny the expansion is carrying everything toward, a universe run all the way down to nothing, and the empty sky of the lone galaxy is only an early station on that road. Which says something humbling about where we sit in time. We tend to think of the universe as old, 13.8 billion years, and it is by any human measure, but set against the full future ahead, the trillions upon trillions of years of slow cooling and fading, the universe is not old at all, but barely newborn. We are living in the first bright, brief morning of a night that goes on almost without end. The stars still shine, the galaxies are still visible, the sky is still full, And all of that is a feature of the universe's extreme youth. The long, dark, empty future is the universe's normal state, the condition it will spend nearly all of the time there will ever be inside. We arrived in the rare early light, and we will not be here to watch the dark come down, but it is coming, slowly, certainly, carried in on the same expansion that keeps the edge forever beyond reach. Let me linger on the one great event still ahead of us in the near cosmic future, the merger that makes our final island, because it is the last large thing that will ever happen in our patch of sky. In about 4 to 5 billion years, the Andromeda Galaxy, which has been falling toward us for a long time, will arrive. The two great spirals will pass through each other, their stars so widely spaced that almost none will actually collide, but their shapes torn and flung into long streamers by the gravity, pulled apart and drawn back together over hundreds of millions of years until they settle into a single new galaxy, larger and rounder than either was. Any world that survived in either galaxy would see, across that span, the sky slowly fill with the oncoming spiral, then blaze with new stars born in the turbulence of the collision, then settle into the unfamiliar shape of a merged galaxy that has no proper name yet, though people sometimes call it Milkomeda. We will not be here to see it. The Sun has only a few billion years of steady life left, and the Earth's own span for life is shorter still, so the merger will unfold long after our world has become uninhabitable, and quite possibly long after our species is gone. But if anything descended from us, or anything at all, is watching from that merged galaxy in the deep future, it will do so already half cut off from the rest of the universe, the distant galaxies well into their long retreat, the sky already thinning toward the emptiness to come. The merger is the last great external event our region is given. After it, there is only the slow leaving, the reddening and fading of everything beyond the bound island until the merged galaxy hangs alone and the dark closes in for good. Let that settle, because it says something profound about our own moment. We happen to live early, in a narrow age when the universe is still young enough and small enough that its light still fills our sky. When the other galaxies have not yet fled, when the microwave glow of the beginning still reaches us. When the evidence of what the universe is and how it began is still, for now, readable. That age is open now. It will not stay open. The very facts we have spent this whole night discussing, the 2 trillion galaxies, the expansion, the edge, the beginning, are things we can know only because we exist in this early, well-lit age. A civilization that comes late will be born into a cosmic dark, cut off from the truth of its own universe, unable ever to learn what we already know. We are not only watching the universe recede beyond our reach, we are watching the evidence of the universe itself slowly being carried away, and we happen to have arrived in the brief span when it can still be seen. I want to be honest that this future rests on dark energy continuing to behave as it does now, driving the expansion ever faster, which is the mainstream expectation, but not an ironclad certainty, because the deep future always carries some uncertainty, and dark energy is the thing we understand least. But this is not idle speculation. What I have described is a careful, published, mainstream conclusion drawn straight from what we measure, under the universe as we actually find it. The sky empties, the evidence fades, and the late civilizations are born blind, which brings us all the way back to where we started, to that edge at 46 billion light years, and to what it was really telling us all along. So let us go back to the edge, now that we know what it really is. We began with a simple picture, a boundary 46 billion light years away, a wall of oldest light, and a natural question, how long would it take to get there? And the answer we have uncovered is not a distance and not a duration. The answer is that the edge was never a place at all. Put the whole thing together. The edge is real, and we have measured it, 46 billion light years off in every direction, the curtain of the universe's first light. But it is a horizon, and a horizon recedes. No one can reach it, and the reason is not that they are too slow, because we saw that even light, the fastest thing there is, launched today straight at the edge, travels forever and never arrives. The ground itself opens between us and the edge, faster than anything can close it, and it opens faster every year because the expansion is accelerating. And the edge is not even the real barrier. The real barrier is far closer, the event horizon at around 18 billion light-years, and most of what we can see already lies beyond it. Around 94% of the galaxies in our sky are already unreachable. Right now, their old light still arriving, while they themselves are gone for good. The small reachable pocket that remains is shrinking, galaxy by galaxy, as more of the sky crosses the horizon and fades. The universe is almost certainly full of other civilizations, and nearly every one of them is sealed away from us, and us from them, by that same expanding dark. And in the far future, the sky empties entirely, until any surviving mind sees only its own lone galaxy, and can never learn there was ever anything more. So what was the edge, really? It was never a destination we were too slow to reach. It was the outer name for a truth that runs through the entire universe, the gap between what can be seen and what can be touched. We can see almost without limit. Our telescopes gather light from 2 trillion galaxies, from the first glow of the beginning, from across 93 billion light-years of space, and we can reach almost none of it. We are like someone sealed behind thick glass, looking out over an endless landscape, able to see mountains and rivers and cities stretching to the horizon and beyond, while the glass will never open, and the one door leads only to a small walled garden, and even that garden is slowly shrinking. The seeing is nearly infinite, the reaching is nearly nothing. There is something almost defining in that, if you sit with it, something that says what kind of beings we are and what kind of universe we are in. We are, above all, observers, watchers. The universe made us able to see almost without limit, gave us eyes and instruments that gather light from the very edge of the observable, from the first moment light could travel, and then it placed almost all of that forever beyond our touch. We are built to look at a universe we cannot enter, and perhaps that is not only a tragedy. To witness something is not nothing. The far galaxies whose light reaches us tonight will never be visited by anyone from here, but they are seen, they are known, they are counted and understood, and that understanding exists nowhere in the universe except in the minds of beings like us who happen to look up in time. The light that crossed billions of years of expanding dark to reach us did not arrive at nothing. It arrived at someone who noticed. I think that is why the size of the universe, once you truly feel it, does not have to crush you, even though the reaching is hopeless. Because the same enormous, unbridgeable universe that we can never cross is the one that made beings able to comprehend it, and that comprehension is real, and it is rare, and it is ours. Somewhere in the emptiness, on one small world, in one ordinary galaxy near the edge of one supercluster, matter arranged itself into things that could gather the light of 2 trillion galaxies and work out the shape and the size and the history and the fate of the whole. That has almost certainly happened elsewhere too, on other worlds we will never reach. But it did not have to happen anywhere, and it happened here. The universe cannot be crossed. It can be known, a little, by the things inside it that learn to look, and that knowing is not lessened one bit by the fact that we cannot travel to what we know. So the last thing I want to leave you with is not the loss, though the loss is honest and real. What remains is the looking. On the next clear night, when you find yourself under the stars, remember that the faint light reaching your eyes has crossed distances no ship will ever cross, from galaxies that have already slipped beyond any reach, arriving after billions of years at the exact moment you happen to look up. You cannot go there, no one ever will. But you can stand in the ancient light of it and understand what you are seeing and know that you are among the few things in all that emptiness that the universe became able to see itself through. The edge will keep running, as it always has and as it always will. The far light will keep leaving, and for the brief lit while that we are here, we get to watch it go and to know exactly what it is we are watching, which is not nothing, which was never nothing at all. It changes how the night sky looks, once you know all this, and I do not think it changes it for the worse. The stars overhead are our own galaxy, the island we keep, the one part of all this that will not be taken. Beyond them, invisible to the eye but there, are the 2 trillion others, almost every one already past the line, already gone, still shining at us anyway, with light that set out before there was anyone here to receive it. That light has been crossing the widening dark for billions of years, on its way to an appointment with a species that would not exist for almost the whole of the trip, and it arrives, faithfully, tonight, at instruments and eyes that can finally understand what it is. There is a kind of grace in that, in the fact that the light got here at all, that it found someone home. The galaxies could not have known. The universe was not aiming at us, but the light arrived, and we were here, and we looked up, and we worked out what it meant, and that happened in a universe that had every reason to be witnessed by no one. And there is one more thing I keep turning over, which is how narrow the age of the looking really is, measured against everything. The universe has already run for 13.8 billion years, and it has, ahead of it, a future measured not in billions of years, but in numbers so long that billions are a rounding error inside them. Against that whole span, the age in which galaxies are still visible, in which the sky is still full and the beginning still readable, is a thin, bright sliver near the very start. Almost all of the time there will ever be lies in the dark afterward, when there is nothing left to see and no way to learn what once was. And we are here, in the sliver, with working eyes and working instruments, and a sky still crowded with the light of 2 trillion galaxies. Whatever else is true about our position in the universe, and most of it is humbling, that piece of timing is close to miraculous. So when I look up now, after all of this, I do not feel only the loss of a universe I can never cross, though that loss is real. I feel the strangeness of being one of the things through which the universe became able to see itself. We cannot go to the edge, no one ever will. But we can stand here in the brief lit morning of everything and take the measure of it, the whole 93 billion light years of it, out to the wall of first light and hold that measure in our heads, which is a thing the mountains and the voids and the 2 trillion silent galaxies cannot do. The reaching was never going to be ours, the seeing is. And for the little while we are here, in the light, before the dark comes in and the far galaxies finish leaving, the seeing is a very great deal, and the edge, that far wall of light, is simply the farthest point of the seeing, the boundary of a view into a universe we were never able to enter. There is a way of holding this that is not despair, and I want to offer it, honestly, without pretending the hard facts are softer than they are. Here it is. We happen to live at the one time when the looking is still possible. We are here in the bright early age, when the light of the whole universe still reaches us, when the galaxies have not yet fled, when the beginning still glows at the edge of the sky and we can read it. Every fact in this video, the size, the structure, the expansion, the edge itself, is knowledge available only to a civilization lucky enough to exist now, before the dark comes in. We cannot reach the universe, but we arrived in time to see it, all of it, out to the edge, which is something no civilization born late will ever be able to do. We are among the ones who got to look while the looking was good. And so I keep returning to that beam of light, the one we sent out at the very start, aimed at the edge, following it outward. It is still going. It will always be going. It crosses the reachable galaxies and passes beyond them, out through the void, past the last things it will ever catch, and then on, into the widening dark, chasing an edge that runs ahead of it faster than it can fly. And it never arrives, and it never stops, for the whole infinite future of the universe. That beam is us, and it is everyone, every civilization that ever looks up and wonders how far it could go. The answer the universe gives back is always the same. You may look as far as you like, you will arrive nowhere. The edge is not a wall you failed to reach, but the shape of a universe that was always meant to be seen and never held. And out there, right now, in every direction, the far light is still leaving, still crossing the dark toward us, carrying the image of places that are already gone. I keep coming back to that edge, 46 billion light years away, the wall of old light we can measure but never touch. When I started thinking about all this, I pictured the edge as a place, somewhere you could go if only you were fast enough, and patient enough, and lived long enough. It is no place at all, but a horizon, and a horizon is not a destination but a limit a line that moves with you and away from you and can never be walked to. The universe is full of light we can see and can never reach, of glows that left their galaxies billions of years ago and crossed all that emptiness to find us, while the galaxies themselves have long since been carried beyond any road we could ever build. We are not too slow. Speed was never the problem. The ground itself is opening between us and almost everything, faster than light can close it, and it opens a little more with every second that passes. So the universe is almost certainly crowded with others, on worlds we will never see and could never reach, each of them sealed as we are inside a small and shrinking pocket of it all, looking out at a sky full of places that are already gone. The edge was never waiting for us to arrive. It was only ever the shape of how much of the universe we were always going to have to watch from a distance and let go of and never hold. We can see almost forever, we can reach almost nothing, and the far light keeps leaving. If you would like more nights spent out at the far edge of things like this one, subscribing is what keeps them coming. Sleep well.